Okay, ji, Bismillah Rahman Rahim. Now let's discuss how you can achieve the reverse Polish notation, also known as the postfix notation, from this statement in infix notation, right? So the reason we do this is that we want to create a more easily understandable version of your operator precedence for the language translator. So basically, this is our input, this is our infix representation, and it should generate our this should be our output. Now, basically, the way this representation works is that you can use a stack line to maintain the operators, and basically the stack, as you remember, the stack is operates in the last in first down principle, and everything that is entered last is basically popped first, right? So we push and pop elements in a stack. That it operates the concept under the concept of how a stack should work, right? So we've also always seen these operator precedence. We've seen it since we've been young. This is what we've been using for all our mathematical operations. And let's see what happens here when I have these set. We have a certain set of rules to follow now. So for example, if I have this infix line right here, my language translator will start analyzing, or in fact, we start reading it from the left, right? Start reading each character at a time. But if the first thing on the left we see is a character, if in fact it's not a character, you can say that it's an identifier. If it's an identifier or an operand, we'll simply put that operand in the RPN line. So notice that since A is an operand, it comes from it. It is no, without any questions, without any decisions, you simply place that identifier or operand directly in the RPN line. So that's why A ends up directly in the RPN line. Since A has left the infix line, the next thing we see is an opcode. This is plus. Now for opcodes, we have to take certain decisions. For this operator, we have to take certain decisions. Now the decisions state that if my stack is empty or has a lower precedence operator in it already, okay? If the stack is empty or has a lower precedence operator in it already, in which case you will simply place this new operator on top of that. So since my stack is empty right now, I will simply place this plus in my stack like so. So it has left my infix line and ended up over here. The next thing we see is B. Since B is an operand, it will simply come into my RPN line. The next thing we see is division sign. Now division has a greater operator precedence than plus. So again, the same rule applies that we just discussed right now. If my stack is empty or has a lower precedence operator in it, then I will simply place this new operator on top of that. Since my stack already has plus in it, plus has lower precedence than division, I will take this division symbol and place it on my addition sign over here. So this division symbol comes on top of my plus sign. Then we have, actually, by the way I've represented stack here is that the rightmost element is on the top. So my stack is, instead of growing upwards, is growing towards the right. So any element mentioned on the right is actually the top of the stack. So after the division sign has entered on the top of my stack, we have a C. Since C is an operand without any decisions, I will simply place it at my RPN line. Then we have a multiplication sign here. Now, the thing about multiplication is that it is the same precedence as division. Now, this is where my second rule comes in. The second rule states that if my stack has an equal or higher precedence operator on top of it, I will first pop that operator and place this new operator in place of that. So I repeat, if my stack already has a higher or equal precedence operator, I will pop the operator and place this new and push this new operator in place of that, right? So let's just say that my stack right here, as you can see here, has division on top of it. Division and multiplication has the same precedence, in which case, before I place this multiplication in the stack, I have to pop this division. And that's when when an operator is popped from here, it will simply be appended to my RPM line like so. So you notice here, my division takes the place of, my multiplication takes the place of my division, And it's simply the division that has left my stack and ended up over here. Now, when we reach something like a bracket over here, now bracket, by the way, as we understand brackets have to be dealt with first. So any operation that's handled in the bracket has to be carried out first before anything outside the bracket takes place. So in that case, highest priority is given to all operations inside the bracket. So how do we deal with the bracket in my RPM is basically we treat the bracket as a separate statement on its own. So what that means is that I will treat E plus G as a separate statement that starts from this opening bracket and ends at this closing bracket. So notice that I have this opening bracket here. Since bracket has the highest precedence, so I will simply push that bracket on top of my stack. Then I have E, it's an operand. I will place that E over here. Then I have a plus. Now imagine that my stack is currently empty. There's, I'm treating it as a separate statement. So that means anything before this, a bracket should be ignored for the time being. So I have this plus, I will simply place that plus on top of my stack. Then I have G, I will place my G over here. Then I will bracket close and I will close my bracket over here like this. Do you notice that after my bracket close, the bracket statement is finished? And you can say that this E plus G statement within a statement is finished. So once I have a closed bracket over here, what I do is simply pop everything that is enclosed inside these two brackets. So you notice that there is only this plus sign that came after the bracket open and now the bracket is closed. In which case, after my G, I will simply place this plus that is popped from here. So that E, because it was an operand, it came over here. Then this plus ended up my stack. Then G, which was an operand, came here. Then this bracket close came on top of my plus sign, because of which now this statement is complete. This bracket is complete, and I will proceed towards popping everything within inside the bracket. There you go. We popped the plus and it ended up over here. So the one thing to note here is that you don't have to mention the brackets over here. So you can ignore that. Simply ignore the brackets and only write the operands inside the bracket. So they can be more than one, opcodes inside the bracket. So there can be more than one opcodes inside the bracket, but in this example, we only have one opcode right here. So we will pop this plus and end it up over here. So again, I repeat that within the bracket, you have to treat it as a completely separate statement. So if you are dealing with an opened bracket, for the time being, ignore everything before that bracket. You deal with the brackets, open bracket, all the opcodes inside that bracket and every operand as well. And you do this until you get the bracket closed. Once you get the bracket closed, only then you will proceed, you will pop everything inside the brackets, and then you can proceed towards anything after that has been in the stack before the brackets, right? So since the bracket is closed, this plus has been popped over here, and this is what is remaining of my stack. Back to the previous statements. Then we have this plus sign here. Now, plus, the rule states that if the stack has an equal or a higher precedence, in which case you see that my stack already has a higher precedence operator, in which case I will pop the operator that's currently in the stack, in which case the C plus, this multiplication leaves my stack, this leaves my stack. Now I am trying to add this plus in my stack. Notice that I already have a plus in it. So equal or higher precedence, you will pop the previous operator, in which case this plus, one of these pluses will leave. So one plus is gone and comes right over here. And this plus that I just entered is pushed right here. Then I have H. H is to be operated at the end, simply just like this. Then I have minus. Now minus and plus are equal precedence. In this case, I will pop the plus and place the minus in place of that. Then I have F operand, put it right here. Then I have multiplication. Multiplication is higher precedence than minus. So that's why my multiplication will simply be placed on top of my minus. And then I have I operand, push it right here. And now my statement infix line is finished. And my stack has these two operators in this. Since my infix line is finished, I will simply proceed in towards popping these statements in my stack, popping the opcodes in my stack. The first thing to go is multiply, then my minus. Now, since my stack is also empty, that means I have achieved the postfix notation for this infix notation, right? So just last, summarize, just to summarize what to do with opcodes. If my stack line is empty or has a lower precedence operator, then the new incoming operator will simply be placed on top of the stack. Secondly, if my stack has a higher or equal precedence operator, like this, then the operator that's currently on the top is popped first and placed at the end of the RPN line. And the new operator is placed in place of that in the stack. If we are dealing with brackets, the opcodes before the bracket open are to be ignored for the time being. And a bracket is supposed to be treated as a separate statement on its own till we reach the end bracket, close bracket. So I will simply start pushing the opcodes after my open bracket in my stack. And once I reach the close bracket, I will pop everything within the bracket only. And that's my bracket. This is my bracket precedence taken care of. So this is how we achieve our, okay, at the end, when I have completed my infix line and all operands I have mentioned here, and I have a few opcodes in the stack, in that case, simply start popping the opcodes in the stack and adding them at the end of your infix line. Postfix line. And this will result in your postfix representation of this infix statement. Similarly, if, say, for example, you're asked to solve something like this. Now, let's just say I have a statement that is already written in RPN and I want to evaluate it. Now, this is how your translator will most probably do it. Now, let's look at this example. You can see here that x2 multiply y3 multiply plus 6 minus. This is an RPN representation. Now, if I were to evaluate this statement, I would have to have some meaning for x or some meaning for y. And that is stated in this statement over here, that x could be treated as 3, y is treated as 4. Now, to solve this type of question, what we can do is we can use a structure like this. And you are often given these blank spaces in your question paper as well. So what we do is we simply push elements here as we see them from left to right. So the first thing I see an x. So, but since x is to be treated as 3, we see 3 has been pushed into the stack. Then 2, then 3 followed by 2 in the next step. See, it's a stack, so 2 comes on top of it. Then we see this multiplication sign. So if I see a multiplication sign, what I do is I simply apply this operation on these last 2 values and push the result back in the stack. So this multiplication will multiply 3 multiplied by 2, and the result will be 6 stored back at the stack. After that, I see a y, which is 4. Y4 is pushed on top of here, followed by another 3 pushed on top of the 4, and followed by a multiplication sign. This is right here. So now, since we have an opcode here, I will perform this operation on the last 2 statements. So that means 4 multiplied by 3, 12 pushed back on the stack, 6 over 12. Then we have plus over here. See, after multiplication, we have plus. That means I will now apply the addition of 6 plus 12, and we get 18 over here. Result pushed back over here. Then we have after 6, we have, after plus, we have this 6 over here. 6 is pushed on top of 18. Then we have division sign. Again, division, you notice that I've mentioned that 6 plus 12, I've said 3 multiplied by 2. So the way this statement is read is that we read this statement first, followed by this opcode, then this one. 4 multiplied by 2. So the lower statement comes first. This is significant, especially when we're talking about subtraction and division. Multiplication, addition makes no difference, but subtraction and division does. So will this statement be treated? Well, we've got 18 divided by 6. So 18 divided by 6 will result in 3. If I don't do that, and say, for example, I treat it with this statement first, followed by this one, 6 divided by 18 will not produce the right result. So this one, the lower operator has to be treated first, 18 divided by 6. It has to be read first. 18 divided by 6, and the result will be pushed back on the stack. So this is how we can evaluate an RPN statement into its equivalent value, right? Like so. And you may also be required at some point to convert an RPN statement back to its infix representation. We can use a similar method to do this, minus the association of variables with their actual values. Now, for example, I have this statement written in RPN, reverse Polish notation, postfix notation, and I want to convert it back to infix notation. So I should end up back over here. How do I get over here? Let's see. I see a B, I push that. It's an operand, push that here. Then I see an A, I push the A on top of B. Then I see a multiply. So that means I will do B multiply by A and push the result back in the stack. So that's why B multiply A is right over here. Then I see a C pushed on top of that, then a D pushed on top of C, and an A pushed on top of D. Then we have a plus sign. So that means I will carry out the addition of the last two statements, which is D or A. D plus A, result pushed back over here. Then we have another addition here. Then we have another addition over here. See, another addition. So that means now this time we're adding C plus D plus A. So result is pushed back over here. Followed by subtraction, this final statement of here, subtraction. That means is that I'm subtracting this statement from this statement. Now, based on our convenience, I can choose to write brackets because this statement has to be treated separately. So to ensure separation, we can add brackets where needed. So we add a bracket around here, and we can also add a bracket around here. So just to be on the safe side, if you're required to do this, add brackets whenever you have a complete expression. So I add bracket around B multiplied by A as soon as B multiplied by A was pushed into the stack. So right, as soon as I say B multiplied by A, add brackets here. As soon as you see C plus D plus A, add brackets over here. And this is how you can ensure operator precedence. So I did that to create segregation here so that we know that first C plus D plus A has to be added. Then the result of that should be subtracted from B multiplied by A. So in that case, I can add a bracket around B multiplied by A as well, just to show that this statement has to be carried out first. This statement has to be carried out first. And the results of two statements should be subtracted like so. So this is how you can evaluate from RPN back to infix notation.